Hi to all. Today I am going to explain the reflecting telescope. Okay, this is our topic. Our topic is the reflecting telescope. It is also called as Cassegrain's telescope. What is the use of this telescope? Telescopes are generally used to see the distant objects. These are used to see the distant objects. Let us see the construction and diagram. Previously, refracting telescope we discussed. In that refracting telescope, astronomical telescope we discussed. That in that lenses they are using. But in this we are using the mirrors instead of lenses. Now let us see here the diagram I am going to draw here. And now this is a convex mirror. You see here. This is a convex mirror. Sorry, it is a concave mirror. This is a concave mirror, parabolic mirror. Concave mirror. It act like a objective. Okay. And now it is also have one telescope, one eyepiece. For the eyepiece, convex lens is used. This is the eyepiece. And now we will take the working. It also has one more lens, one more mirror, that is the convex mirror. This is the convex mirror. This is the construction. You see here, the reflecting telescope has a concave mirror, parabolic mirror, okay, and one convex mirror. This is the convex mirror. The B is the convex mirror. You see here, this is the convex mirror. And now let us take the two light rays. For example, one light ray is allowed to incident like this, and another light ray incident like this. It's a mirror. There is no loss of energy. Then the total light will be undergoes reflection. The light will undergo reflection like this, and this light also undergoes the reflection like this, and it is incident at here. After that, again it will be reflects, and this will also reflects, and all the two reflected light rays are meet at the eyepiece. Okay, and now at the eyepiece we can see the image. That means image of distant objects. From the distant objects, light rays generally incident parallelly. Distant objects, the light rays incident parallelly. These light rays are reflected by the concave mirror, and they are allowed to incident at the convex mirror. Then the convex mirror again reflects the light rays and allowed to meet at the eyepiece. Then image will be forms. Means image of distant objects will forms, and that will be observed by us. And this is the convex lens we are using it here as eyepiece. Now let us see its construction and some information I will give regarding this. And this is the diagram for that. Okay, and this is the objective, and that is the eyepiece. Now the telescope. This is the telescope. It is a reflecting telescope. What it consists? It consists a concave mirror. This is the concave mirror or the parabolic mirror, and also convex mirror. One eyepiece. Eyepiece is convex lens only. What happening at here? The telescope in which the objective is a curved mirror. Objective is a curved mirror. Is called as reflecting telescope. What is a reflecting telescope? Reflecting telescope means we are instead of lenses we have to use the mirror. That means Generally, refracting telescope previously we discussed. In that, we are using the two convex lenses. One is objective and other is eyepiece. And in this, but in this again we are using the two things. One is objective and other is eyepiece. But the objective is a mirror. Okay, right? Curved mirror. The telescope in which the objective is a curved mirror is called as a reflecting telescope. What we can call it as reflecting telescope. We can call it as reflecting telescope. And now let us see it's working. Okay, a light ray from distant object, we can take distant object as star. A light ray from distant star after reflection after reflection from a concave mirror, from a concave mirror, a fall on convex mirror, that is B, and allow to converge at a convex lens that act as eyepiece, that act as eyepiece. Okay, and this is the some construction and some working it here. What happening, once again I will explain. This is a light ray. You see the figure in the red line cursor, you see this is a light ray. Light ray from distant objects parallelly incident. If the object is at infinite distance, light rays comes parallelly like this. These light rays from distant star, they undergoes reflection at the concave mirror. After the reflection, they are allowed to incident on the convex mirror, and then the after the from the convex mirror it undergoes the reflection and they will meet at the convex lens that act as eyepiece. Then the image forms at here, right? And then that is observed by us. Distant object image will be forms at here because the light rays are converging, meeting at this point. Where the reflected or the refracted light rays are meet with each other, there the image will be forms. Here the reflect light rays are meeting at the eyepiece, there the image will be forms. Light ray from distance star after the reflection from a concave mirror A fall on the convex mirror. This is the light ray from distant objects after the reflection from concave mirror incident on the convex mirror, and this convex mirror allowed the light rays to meet at the convex lens that act as eyepiece. Then the final image will be forms, right? Okay, now let us go for some more important point. What are the advantages of reflecting telescope over refracting telescope? Okay, right, let us see here. Before this, you take the screenshot and note it, and then I will continue in the next page. I'm going to erase. Okay, now I am going to continue. I am going to explain a few things that you see the cursor. It is advantages of reflecting telescope over the refracting telescope. In the reflecting telescope, we are using the mirrors, but in the refracting telescope, completely we will use the lenses. Due to the lenses, there are some aberrations are there in the formation of image. Aberration means defect in the formation of image. Refracting telescope is better than the refracting telescope. Why reflecting telescope is better than the refracting telescope? And what are the advantages of the reflecting telescope over the refracting telescope? That we are going to discuss. These are the very important. First point is that image is free from chromatic aberration. Which is free? Image formed by the reflecting telescope is free from chromatic aberration. And why? Because in this we are using the mirror. If you use the lens, then the chromatic aberration will be there. Chromatic aberration means color defect. It is called as the color defect. Different colors will form the different images, and color images will be forms. This is a chromatic aberration if you use the lenses. And the second point is that the image formed by the reflecting telescope, it is the free from spherical aberration. No, there is no spherical aberration. Spherical aberration means due to the convex surface or the concave surface, this aberration will occur. All the light rays which are incidenting at the edges of the lens, they will focus at one point. All the light rays which are incident near the principal axis at the midpoint, near the optical center, they will focus at some other points. Due to that, the extended image will be formed. That is the spherical aberration. Spherical aberration due to the convex surface occurs, and the chromatic aberration due to the color occurs. This is a color defect. Okay, and it is the shape defect. Due to the shape, it will occurs like this convex shape, spherical shape. And this third point is that image is bright in the reflecting telescope. Why? Because there is no absorption of the light energy, there is no loss of energy. If the light refracts, then it is passes through the lens. During that, the lens may molecules may be absorb some light, right? And during the reflection, there is no loss of energy. That's when the image forms with more brightness. And the reflecting telescope is a lightweight. We are using the mirrors. Mirrors are lightweight comparing to the lenses. That's why it is a easy mechanical support. We can fix easily. Okay, once again I will tell what are the advantages of reflecting telescope over the refracting telescope. Reflecting telescope is better than the refracting telescope. Why? First one, in the reflecting telescope, image is forms without chromatic aberration. Chromatic aberration means it is a defect in the formation of image. It is a color defect. And image formed by the reflecting telescope is free from spherical aberration, free from chromatic aberration, free from spherical aberration, and image is more bright. And reflecting telescope lightweight and easy mechanical support. These are all advantages of the reflecting telescope. And now, what are the limitations? And one more advantage: high resolving and magnifying power. Okay, the size is much more image size than object size. Resolving means every part in the object appears clearly. Limitations of astronomical telescope. Okay, image astronomical telescope means refracting telescope. In that lenses we are using. In the lenses, there are two types of aberrations will be there in the defect in the formation of image: the chromatic aberration and spherical aberration. Right? And in the refracting telescope, image suffers with the chromatic aberration. Image suffers with the spherical aberration. Small magnifying power, small resolving power, and one more point is the large mechanical support is required. Okay, high mechanical support is required. More mechanical support required and difficult to fix lenses with large size. Okay, and this is about advantages of the reflecting telescope. And what are the advantages of the reflecting telescope? Okay, I gave that. Reflecting telescope not have chromatic aberration, not have spherical aberration, image is bright, and reflecting telescope easy mechanical support. And astronomical telescope, these only falls in the astronomical refracting telescope. What are the faults in refracting telescope? Chromatic aberration is there, spherical aberration is there, less magnifying power, less resolving power, difficult to mechanical support, right? Thank you for watching my lectures. Thank you to all.